So that's going to be anti-diuretic hormone. Now, what is the stimulus to the production of anti-diuretic hormone? There are several of them. We're going to start with the simplest. We're going to call it a dehydration. Okay. So now bear with me. Some of you have taken chemistry before in high school, maybe. Have you? Very, very basic. Okay. So if you lose water, like you were working out in the sun, you sweated a lot, you lost a lot of water, just water. What happens to the concentration of the solutes, of the electrolytes in your blood? Does it go? When asked questions like this, the answer is usually up or down, so increases or decreases. So when you lose just water, what happens to the concentration of electrolytes in your blood? Increases, because you're losing water. Does that make sense? So we say that osmolality of your blood or extracellular fluid goes up. Okay? Clear? This increased osmolality triggers the release of anti-diuretic hormone from the posterior pituitary. We good so far? And now ADH acts on the kidneys, specifically on the collecting ducts. So ADH increases water reabsorption in kidneys. Does that make sense to you? Now, when you increase water reabsorption, when you start taking water out of your urine, what happens first of all to osmolality? When you bring water back into the blood, what happens to the concentration of all the solutes? Decreases, yes, it goes down. So first, osmolality goes down. Does that make sense? Okay. What happens to the urine volume? Remember, you take water. When we say reabsorption in kidneys, we're taking water from the urine and bringing it back into the blood. So what happens to the volume of urine? Decreases, yes. What happens to urine concentration? I'm not going to help you this time, just think through. What happens to urine concentration? Increases, because you take water out of it, right? Are you following me so far? What happens to blood volume? Increases. When your blood volume increases, what happens to your blood pressure? Yes. So here's my second question. We obviously, the osmolality thing here, the osmolality thing is a stimulus. But considering other outcomes, what are other stimuli for ADH production? If the resulting effect is increased blood pressure, what can be another stimulus? Exactly. So low blood pressure. It's a pretty typical response, and essentially, low blood pressure and, check this out, blood loss, bleeding, is also a trigger for ADH. Does that make sense? Now, it all sounds very fundamental. So you worked out in the sun, or I don't know, you mowed the grass, okay? And you were sweating, and now you walk in your house after like an hour and a half of heavy workout outside in the sun. What are you going to do right away? Like, what do you feel? how do you feel after working out and sweating a lot? And exhausted, yes, but specifically about water. Thirsty. You know why you feel thirsty? Because of ADH. It stimulates thirst. If you donated blood, pretty often after the blood donation, you feel thirsty because you just lost a pint of blood during the donation. And that loss of blood triggered the release of ADH, which made you thirsty. Does that make sense? Now, the good so far? Pretty boring, right? I know. So, one of the effects of ADH, interesting effects. Another name for this hormone is vasopressin. Now, vaso refers to blood vessels, and pressin refers to compression. So if you look at the name, vasopressin, compression of the blood vessels, right? So it makes blood vessels narrower. When your blood vessels become uniformly narrower, what happens to your blood pressure? Increases. So ADH also results in vasoconstriction. Which increases blood pressure. Does that make sense? It's actually very elegant hormone. We good so far? Well, so if you will drink a pint of beer, or 2 pints of beer, you will want to go to the restroom pretty soon, right? But if you will drink 2 pints of water, the effect will be the same. Makes sense, right? Now imagine you're not drinking beer, but you are drinking hard liquor, like vodka. And you're drinking shots, pretty low volume, correct? However, if you keep drinking shots, eventually you will have to go to the bathroom. The amount of urine that you will start producing will not match the amount of liquid that you take in the form of vodka. So you may drink, I don't know, like 4 ounces of vodka and pee out half a liter of urine. Why does that happen? Turns out alcohol is an inhibitor of anti-diuretic hormone. Does that make sense? And if you block anti-diuretic hormone, water reabsorption in kidneys decreases. Does that make sense? Volume of urine increases, and concentration of urine goes down. So, when you drink alcohol, you produce basically a large volume of a pretty diluted urine, and next morning the hangover is the result of dehydration. Does that make sense? So actually, sort of one of the treatments, one of the preventative measures, if you drink alcohol, is to consume a lot of just liquid like juice or water or mineral water to compensate for the lost fluids. Does that make sense? This is kind of an underlying effect of dehydration. Questions about ADH? You good? Okay.